All right, so we're going to start today in Chapter 10, and Chapter 10 is counting methods. So we're not going to actually get into probability, which is Chapter 11, but Chapter 11 is based on Chapter 10, and it's about how we calculate probabilities of winning things. So think about things like when you watch, the poker people, or when you're talking, Poker Channel, right? And they give you these percentages when the cards flip about who's most likely to win. They're using counting methods to do that. Granted, of course, they're using a software to do that, but they're doing it based on what we're going to take a look at learning in this particular section. Okay? So the first one that we're going to talk about in this section is counting by systematic listing. And when we have small groups of things, systematic listing is very convenient and it's pretty easy to do. All right, so we're going to consider a group of students, Abigail, Bailey, Nate, David, Elias, and Macy, and we're going to list the different ways of forming the following groups. So, let me just read part A. All right, so number 1 says, a president and a treasurer if they are not of the same sex. So let's go back first to make sure everybody's clear. I don't think in this class we have any students who are non-native English people, are you? I don't think so. My other class does. But we want to make sure we recognize, looking at names, which one's actually the boys and the girls, or we're not going to be able to do the question, because sometimes names don't always have that same sort of thing going on. So we're going to deal with that first. Look at that. Abigail would be a girl. That's my daughter. Yep. Bailey, also a girl, just in case you weren't sure. Nate, typically boy. Yeah, boy. David, boy. Elias, boy. Although I tell you what, sometimes teachers don't know when they see his name. That's my son. And then Macy, that's girl. All right, so if you take a look, there's our thing. The other thing you'll notice is that, and your book does this too, is that whenever they give you a list of people's names, they change, every name has a different first letter. So if you really want to write out Abigail every time you use Abigail, you can, but what could you do instead? You could write A. Are you with me? Okay, your book does that on purpose to eliminate some of the writing that you have to do, and you can as well, okay? So the first thing is, it says a president and a treasurer if they are not of the same sex. So what we're going to do is we're going to actually pick, and we're just going to pick the first person in the list, which would be Abigail, and we're going to let her be the president. So when we write these, we're going to write the president first and the treasurer second. Not because it matters, but because we have to pick something, so we're just going to pick that, okay? So one option is that I have Abigail be president, and if Abigail is president, who could be treasurer?
Any of the boys.
Any of the boys. So we could have Nate, or we could have Abigail and David, or we could have Abigail and Elias. So these are the 3 ways that Abigail could be president. Make sense? Okay. But she's not the only one who could be president. Who else could be president? Bailey could be president. And if Bailey's president, who could be treasurer? Nate or David or Elias. Okay, so let's keep going with girl presidents. There's one more girl in my list. It's Macy. So Macy could be president. And if Macy's president, then who could be treasurer? Nate, David, or Elias. Are we all good with that? Okay, but that's just half of them, isn't it? Because I just have the girls as being president so far. Agreed? So I'm going to do the same thing now with all the boy names. So let's start with Nate because he's the first on the list. I could have Nate president. If Nate's president, what are my different options for treasurer? Abigail, Bailey, or Macy. I could also have, instead of Nate, I could have David. He's next. I could have David with each of the 3 young ladies, right? David Abigail, David Bailey, David Macy. What are my last 3? Yeah, all with Elias, so E's. So I could have EA, EB, or EM. Now, there's lots of ways that you could have done this in an organized list. I kind of picked the one that sort of spoke to me when I looked at it and thought about it, right? You may have a list that's organized differently, but here's the kicker. If you don't organize your list, you're probably going to forget somebody in the list. So be organized when you're listing these out, or you will end up missing something or duplicating something because you'll write it twice because you weren't paying attention. Okay, so the goal is an organized list. How many do I have? 18. So there's 18 ways of doing this. I mentioned that because we're going to come back to this in lesson 2 and talk about that. So just kind of note to yourself now that there were 18 ways that we found to make this happen. Okay? Next question has more going on. What's going on in the next question that makes it more difficult? There are 3 people we're going to pick, isn't there? Aren't there? President, Secretary, Treasurer, and it tells you what? And so is the President, right? So it says the President and the Treasurer are women. Does it say anything about the Secretary?
Nope.
So what does that mean?
The secretary has
It could be either. So be careful not to infer something that's not going on, right? It'd be awfully easy to read this and think, and to sort of in your mind think, oh, and that other one's a man or boy. It doesn't say that, so don't infer more than what they really tell you, okay? So let's start with President who? Abigail. And we'll put the treasurer at the end just so that they're listed in order. President, and then we'll do the secretary, and then we'll do the treasurer. So if I do Abigail as president, who could be treasurer? Pick somebody for me.
Bailey could be treasurer.
Bailey could be treasurer, yeah. Okay, so if I have Abigail and Bailey in these 2 roles, how many different people could go in the middle here for the secretary spot? 1, but how many different options do I have? Not 6, 4, right? I can't use Abby and Bailey again. They've already been used. But I can use any of the other 4 in between because any of them could have that role. So I actually have a NB, a DB, a EB, or a MB. Does that make sense? And that's all the ways I could have Abigail at the front and Bailey at the back. But I could have Abigail and Bailey switched, couldn't I? And that would be a different structure, right? People have different roles, different responsibilities. So I'm going to do this exact same list, but switch my A's and B's around, because that's another 4 options that I've got to include. So BNA, BDA, BEA, and BMA. And I think that takes care of everything that's going to have Abby and Bailey in those roles, correct? So let's pick somebody else. Now who do you want? President. Can we stick with Abby for the moment, Abigail?
Good.
We could. And if we put Abigail still as president, then who would be the treasurer? That would have to be Macy. So we can do AM, and then we have what options? There's 4 of them because there's 4 different people that could be in the middle. Who could be in the middle?
Bailey.
We could have Bailey or Nate, David, and Elias. Now what am I going to do? Switch the A and the M, right? So MBA, MNA, MDA, and MEA. Now what? That's it for Abby, right? I mean, she's done in president role. There's no other options for her as president. Agreed? We've taken care of her. But we could use Bailey and Macy. That's exactly right. So let me draw them down here at the bottom. So I can do Bailey and Macy, and I'll put them in the order that Austin just said. So we'll do B first and M second. All right, so who can go in the middle? Abby or Nate, right? Nate? David or Elias? And then we're going to switch the M and the B. So I'm going to have MAB, MNB, MDB, that's a B there, sorry, and MEB. Did I get them all? I think I did. How many are there? There are 24 this time. Again, it's not necessary at this exact moment, but we're going to come back to this in 10.2 and talk. So I'm going to make you mention of this. There's 24 different ways that this could have been formed. 24. Yeah. All right. What is different about 3? How many people am I talking about first? 2. So it's kind of like part A, right? Or part 1 or whatever. I lettered these. It's kind of like the first one. But what's different? There's no restrictions. That's a valid thing to think about. There's something else, too. I have the just 2 people, but there's something else. What am I forming? A committee. A committee is different because if I'm forming a committee, nobody has titles. So these things where I reversed the order, right, where I moved the A and the B and I switched them, I won't be doing any of that here because switching them doesn't change the committee, does it? Do you see the difference? So we don't have to worry about switching things around to get all the other options. There is no other option. I've already formed that committee once I write it down once. No switching. So let's pick somebody to start my committee. And since she's first, we're going to pick my daughter, Abigail. Who could be on the committee with Abigail? Bailey. Or I could have Abigail and Nate. Abigail and David. Abigail and Elias. Or Abigail and Macy. And I contend that that's it. Abby doesn't get to be in any more committees. Those are the only 5 committees she could be on. Agreed? So I do not have to write her name down again in this particular problem. But there are other committees that Bailey could be on, correct? So we're going to start now with Bailey. Bailey's already been with Abby, so I'm never going to write down another A on this problem, okay? Because I would duplicate what I already did. If I write down BA, that's the same committee as AB. So I'm not writing down BA. But I could write down B what? N for Bailey Nate, or Bailey David, right? Bailey Elias, or Bailey Macy. Notice there's 1 fewer. Why is there 1 fewer? Because I'm not writing BA, right? I already wrote it. So I will have 1 fewer on this list. But now I've written down every possible committee that Bailey could be on. So she's no longer going to be written down in any other forms. I've written all hers down. So how about we do Nate next? Who else could Nate be joined with? You see he's already with Abby on the first list. He's with Bailey on the second list. Who else can he be with? David or Elias or Macy. Again, 1 fewer than the list before, right? Because I don't include Abby, I don't include Bailey. I'm done with Nate. Now I need David and Elias or David and Macy. Done with David, and there's 1 left. Elias and Macy. How many do I have? 15. Okay, are we good? All right, so at different points in this section, we're going to talk about different kinds of games. So the first game we're going to talk about here has to do with if you roll dice. So we're talking about fair dice, that is, they're equally likely to come up on any side of dice. And when we're looking at those dice, they're 6-sided, and it says so as well. It says, consider rolling 2 6-sided dice, then determine the number of ways to get the following sums. Now, before we actually look at the sums, I want you to fill in on this side a nice way of thinking about the different options. So if I had 1 die, what numbers could come up if I just had 1 die? 1 through 6. So I'm going to sort of list die number 1 options on top. And the other die has the exact same options, right? So I'm going to list it down the column over here on the left. So far, so good? Now, there's several ways that I could list what's going to be inside of my table. One way is that I could list them sort of like as ordered pairs. It says 1 die is a 1, die 2 is a 1. So I could write this. Don't write this down. This is not what we're going to do. But one way to do this is to write it like that. Just kind of to list both options. If you look at that, obviously you can say, oh yeah, that's 2, right? That's a sum of 2. I'm actually going to list this out with the sums because the problem actually, if you take a look at the next options, wants the probability of rolling the sum, there it is, the sum of the following things happening. So I'm actually going to write down the sum. So in the first column and row, right there where I just erased here, what I want is I want the sum of the column I'm on and the row I'm on. So if that is to say, I want the sum of rolling a 1 and a 1, which would give me a 2. And if we're going to go across the front here, or across the top here, this would be 1 plus 2 is 1 plus 3 is 4, and so on. So I've got 4, 5, 6, and 7 all the way along the top row. Make sense? But you know what? My first column's that too, isn't it? Because this first column is taking the 1 on column 1 and adding it to 2, to 3, 4, 5, and 6. So this also starts with 2, and then it's 3, 4, 5, 6, and then 7. All good? Does everybody understand how we're filling this chart in? Do you have a question, Austin? Are you good? Okay. Anyone? Okay. So we're going to fill in the rest of it. You'll notice there's some wonderful symmetries. Already you notice the first column and the first row, they match, right? And that's going to happen on every column row that I have. So second column, second row, they're going to match. Third column, third row are going to match. So the second one I've got is 2 plus 2, which is 4. And then they just increase in 1 as I go across. So I've got 4, 5, 6, 7, and 8. If I go down, I've got 5, 6, 7, and 8. The next one is 3 plus 3, so that's 6. So I have 6, 7, 8, and 9. And then 7, 8, and 9 going down. 4 and 4, which would be 8. So I have 8, 9, and 10. And then 9 and 10 coming down. I have 5 and 5, which is 10. So 10, 11, 11. And the last one, 6 plus 6, which is 12. All right, so a few things about this. I already mentioned some of the symmetry. What else symmetry do you see? What's really nice? Yeah, I see everybody going like this with their hands, okay? There's some wonderful diagonals that match, don't they? So if I'm looking for 5, they're all right here. Yeah, so I can find them real quickly. All right, so let's take a look at the ones that we're looking at specifically. The first question wants to know, or the question asks, it reads it this way. Determine the number of ways to get the following sums. And the first one is the number 4. So if you take a look right here, and you're just looking at the chart, how many 4s do you see? There are 3 of them. So there are 3 ways of getting a 4. And just so that we're all clear, you didn't really need the table to do this. It was handy and it's nice to have, and your book has one in it too. But you could also just think about, what could I do? Well, I could get a 1 and a 2, or a 2 and a 1, because there's 2 different dice. Those are 2 different rolls. Or I'm sorry, 3 is the number I meant. Let's fix that. 1 and 3, or 3 and 1, or 2 and 2. There we go. So we could actually list them out and think about them directly if we didn't have a table to look at too, right? Or if the question asked us about the product table, like if it wanted you to do multiplication inside the table instead of addition, you could do it the same way, right? You could multiply the 2 dice to try to get the number 4. I can do 4 times 1 and 1 times 4, or 2 times 2. It would actually still be 3 ways of getting a 4 as a product on the 2 dice. We usually do sums, but it is another option. How about an 11? How many ways are there of getting an 11? 2. And you know what they are. What does the die have to do in order to come up with a sum of 11? Yeah, 6 and 5 or 5 and 6. I mean, there's just no other options, right? How about odd? That actually takes a little bit more work to count because it's not a specific one number you're looking at. How many odd do you have in this table? 18. Tara, do you know how many are in the table? There are 36 in the table. So what is 18 in relation to 36? Half. Does that seem reasonable? Yep, definitely. So if I wanted to know the number that were even, it would also be 18. And the reason that this is 36, besides just that you can count them, is because there's 6 ways to roll die 1, 6 ways to roll die 2. 6 times 6 is 36. That's right. So if I wanted to roll 3 dice, I would have 6 times 6 times 6. And I don't want to count them, but that's how many we would actually have different ways of rolling and sums of coming up on 3 die. All right, we have a couple left, and I bring them up specifically because they're a little bit unusual. The first thing I want to talk about is this word between. What do you suppose between means? Yes, it means that I don't include the 6 and I don't include the 15. So if this says between, it means that I would include 7, 8, 9, 10, 11, 12, 13, and 14. Now, what else do you see that's odd here? Yeah, I can only get a 12. That's the biggest I could get. So even though the 13 and the 14 are listed here, there are no ways of getting a 13 or a 14 if I roll 2 die. Make sense? So really, if I look back at my table, I'm looking and counting for the number of ways I can get a 7, 8, 9, 10, 11, or 12. So go count. What do you get? Can you count the 7s through 12s? Did you get a number? Angela, did you get one? You had 21? Somebody else get a 21? Brandon did? Okay, good. 21 it is. There are 21 ways of getting one of those, what do I have, 6 numbers. 21 ways. All right, so here's another one. So this goes way back if you haven't thought about this language in a while. What does multiples of 3 mean?
3 times anything?
Yeah, those are the exact 2 ways of thinking about it. You guys are right on. So anything that has been multiplied to get the result, any number that has been multiplied by 3 would be a multiple of 3. Or you can think about it as anything that's divisible by 3. So let's, looking back at our table, figure out what numbers that you see in here are divisible by 3. Just list me the numbers for right now. 3, 6, 9, and 12. So what I'm looking for in this particular table is I'm looking for the 3, the 6, the 9, and the 12, and I'm going to count up the ways that I can get the 3, the 6, the 9, and the 12. And what is it? I thought somebody said it. Are there 12?
Yeah.
That's what I have written down. Excellent. There are 12 ways of getting any of those particular 4 numbers. Another thing, I can't remember if it happens in this assignment, but if it even doesn't, it may be on my math lab. What is prime? If they wanted you to look for primes, what would you be looking for? Anything that's only divisible by itself in 1. So looking at this particular table, what numbers in this table, that is the numbers 2 through 12, are prime? 2 is prime? 3 is prime? 5? 7? Not 9, but then 11. Yeah, the tendency is to start listing odds. It's not all the odds, right? But a lot of them at the beginning, I mean, well, yeah, we are going to get a lot of odds, just not all the odds. So yeah, there would be 5 different numbers you'd be looking for if it said prime. I think that that's all the differentiation of the way that they describe those, so we can stop there.